All right, so now we are going to do chapter 7, where we're talking about sampling, also the sampling distribution. Um, I think that I don't know, this is kind of a fun chapter, at least we get to introduce some interesting ideas. Um, oh, not animation slideshow, but let's just jump into it, right? So we've talked already a little bit about we generally want population data, but often we can only get a sample or a small subset of that, right? So really two situations. We either have a finite population. This is like there's some hard fast end of numbers, maybe 50 states. That's our population, every single state. But also infinite population. So this could just be something like, I don't know, human population. Like we don't know where that ends, right? If we're looking across time, it could be some infinite kind of population. Now we're generally going to kind of focus on finite ones. If we did have an infinite population, like there's no way we can ever collect census data. We can't collect every single observation ever. So a lot of the times we just have to rely on using sample data and then using the statistics and the decisions we make from the sample to kind of make our best judgment or inferences about the population data. So we've already talked about this a little bit, but our random sample will be of size lowercase n. It's going to be some subset of the entire finite population size n, right? Capital N. Um, Now it should be that we are selecting each observation in our sample randomly, or at the very least, every single person has the same probability of being selected and put in the sample. And I say people, could be countries, could be companies. So there's two different ways we can do this. It's sample with replacement or sample without. So you can kind of think about the benefits or maybe the pitfalls of both these. So if I did if I did sampling with replacement, that means that I have like 100 names. Maybe I only want to draw randomly 10 of them. I put them all in a hat. I grab one of them, pull it out, write that person's name down. I then put their name back. Shuffle them up, grab another name, write that person's name down. Without replacement would be once I select someone's name, I don't put it back in the hat, I set it aside. So what are the obvious benefits of doing this without replacement? Well, if I did it with replacement, I might accidentally end up having the same person pulled twice in my sample, which means now they're carrying more weight than everybody else, right? Because I've accidentally drawn them twice. So generally, we would like to do this sampling without replacement, right? I say better here. It's not always the case. I know like some of the hard sciences and stuff, there's some sampling with replacement, but for our context of what we're going to be thinking about without replacement. Um, Infinite population, right? Kind of works the same way. We just each element or each observation we select from the infinite population has to be selected independently, and we end up with a smaller subset, right? So, what are some different types of sampling we might see done? So stratified random sampling, maybe I do want a random sample, but if I'm thinking about, oh, let's say maybe I'm interested in the overall political attitude or favorability of the current president, but I think that it might vary across racial groups, right? So I know that my final sample, right, I want to ensure that my sample has demographics or a racial kind of breakdown that looks very similar to the population as a whole, right? So even though I can't collect favorability data from every single person, if I know that on average I have, I don't know, I'm just making these numbers up. This isn't necessarily reflective of the United States, but 50% identify as white, 30% identify as black, and 20% identify as Asian. Let's just say that's my only three groups just to make it easy. Well, then I want to make sure I end up with a final sample that has 50% of the sample is white, 30% is black, 20% is Asian, right? So what will I do? I'll divide my kind of randoms or my individuals up and into these racial categories, and I'm going to randomly sample, say, 50 people from the white category, 30 people from the black category, 20 people from the Asian category. That way, I ensure that the demographics of my sample match up with the demographics of the population. Okay. Um, and then I combine them, right? Once I randomly select those 50, 30, and 20 people, I combine them all to get my full sample, right? So this usually is appropriate when we have two or more groups. So I use kind of racial groups here, but you could think about, maybe I want to make sure that I've got all incomes represented, or I want them to be represented by the same proportion of people who are in that income category as the population, right? Another kind of thought of experiment here is, let's say, excuse me, I'm interested in, hmm, oh, we'll say that example. So I think the racial category example kind of makes sense, and you can kind of think about it as income as well. Um, you can kind of break it up, make sure that, I'm only getting 20 people, or 20% of my population is from the lowest income category, the next 20%, next, so I sample from each one of these income categories, then throw them all together. Cluster random sampling is going to sound very similar. It's just generally we don't do it based off of a characteristic, but based off of kind of some kind of grouping. So if I know that there's subpopulations of the larger population, and I might want to make sure each one of those subpopulations is represented, I'll do cluster random sampling. So this is a good example. Let's say I want to make sure that I have equally represented every 50 or every one of the 50 states. So I'm interested in about the US population. I know that each state is a little bit different, right? There's subpopulations of the whole. So I want to make sure I sample 2 people from every single state. I'll randomly sample 2 people from every state, throw them all together, right? To then get my full sample. Okay. Usually this makes sense when I do have like geographical regions and I want to ensure that they're all represented, specifically if whatever I'm calculating, the variable I'm looking at, say the mean of, if those regions, right, are related to, or do have some influence on that variable I'm capturing, right? So this would be the idea if I'm interested in like overall spending habits in the US. Well, I know that people in New York have very different spending habits than people in Wyoming, right? So I might want to make sure all of them are represented. Another really good example of this might look like political polls, right? So because each state has a certain number of electoral votes, right? What might I want to do? I might want to use kind of a cluster random sampling, but almost like a combination of cluster and stratified because, oops, sorry. What I'm going to want to do is say, okay, look, I know that yes, the overall population, popular vote matters, but really the one that elects the president is electoral votes. So I know that if, for example, I forget the numbers, I probably should be better about this, but let's say, I don't know, California has 50 electoral votes, right? I'm going to want to make sure that of the, sample that I have, maybe I'm going to randomly sample 50 people from California. And then I know that Wyoming has 3 electoral votes. So I want to make sure I only randomly sample 3 people from Wyoming. So I kind of divide the region or the United States up into these regions. I'm taking different numbers and then kind of throw them all together to get my final sample, which has every state represented and has every state represented by the exact same proportion of the electoral votes that they get. Right? So this is how we would see these in practice. Right? So we already said before, it's not usually feasible to get a census. We're relying on this sample data to make inferences about the population. So what could go wrong, right? We're getting a sample. It's just a small subset. We should be pretty safe to make assumptions about the population if I say have a couple hundred people in my sample. Excuse me. So the example that we're going to have here, that I want to set up how maybe some things we should be aware of. So this is a really old example. I then think I have some newer stuff that makes sense. You might be able to already kind of imagine as we're working through this one what I might move towards. So back in 36, FDR beat the Republican candidate Alf Landon, right? So it's a really interesting paper was written about this, and I'll put the PDF up on Canvas. If you're interested, it's not required reading by any means, just there if you're interested. And I'll show you some of the screenshots from it. But they went back and they said there was this literary digest poll. So I don't, none of you probably know what this is. It used to be this little magazine. My grandma used to get it when I was a kid. I don't know. It was basically, I don't know, a lot of current events, things like that. So there's this literary digest poll, and they get this idea of, man, look, this is in like a lot of different households. Let's send this out to 10 million different people. We'll send out this poll. We'll get 10 million hopefully get everyone to respond. We're then going to try to predict the upcoming election. Well, they sent out 10 million, but just like you ignore spam calls and throw away junk mail, a lot of people ignored this survey. But they got a response rate of 25%. So 2.5 million people responded. That's pretty good. I don't know if you've ever done all your experiences, if you work for a company or anything where you're thinking about getting surveys back, it's hard to get 25% back, right? And these responses predicted that a landslide victory. 57% were going to vote one way. The electoral vote, they kind of used this stratified or this cluster random sampling. They had to predict the electoral vote was going to be a landslide, but they predicted it for Landon, right? They predicted Alf Landon was going to win, but we know he lost, right? We've never had a president named Alf, unfortunately. But not only were they wrong, it was a landslide in the other direction, right? Roosevelt cleaned house, right? So how did they get it so wrong, right? Do they make math errors? Did they use this? I'm being dumb here, but did they use this population to sample variance formula? Or maybe what seems more, did they somehow only mail their postcards to Republicans? Or did something they do make it so that they sent more out to Republicans? Or even if they sent 5 million to registered Republicans, 5 million to registered Democrats, did no Democrats respond and 2.5 million Republicans respond, right? Or more Republicans more likely to respond, right? Both of those could have influenced our results. So really this idea is going to be, we can break this down to two different bias. So the selection bias is that somehow I over-selected or more of my surveys were sent to Republicans. So whatever the process I used, maybe for whatever reason, people who tend to vote Republican were more likely to be sent this survey. That's a selection bias. What about a non-response bias, right? Well, a non-response bias is going to be something like you sent 5 million to Republicans and Democrats, but you only got Republicans to respond, no Democrats at all, right? It doesn't have to be that extreme. It could be that, you sent out an equal number, but Republicans, just respond a little bit higher of a rate. Okay. Another good example of a selection bias, we'll look at maybe some data this on, but like anytime you look at drug use, or sorry, I said selection, non-response bias. Anytime you look at drug use, people are like, if they actually are heavy users of drugs, they're just going to be more likely not to respond to your survey. Right? So we should always be concerned about these two biases, right? So in this context of this example, we need to make sure that this literary digest is a sample that reflects the population. Well, the problem is, how did they obtain the names to send these 10 million surveys to? They cross-referenced names in both telephone books and car registrations. So they had a set of names where the only way you got into this database was if you had a telephone number and you had a car, right? Or a registered car. Let's think about who that would be in 1936. Who had their own telephone and their own car in 36? Really rich people, right? In fact, my dad, even growing up, told me that they still had a shared phone line out in the country, right? So they were able to go back, find a bunch of these people who responded to the survey, and then ask them follow-up questions. I forget how many years later. And what they found was that people who had a car and a telephone, 52% of them actually ended up voting for Landon, right? So if you compare the people who owned a car and a telephone, yes, if you were trying to predict what this result of the election is going to be, you would have thought the Republican candidate is going to win. If you looked at who actually voted for Roosevelt, if they only had a car. So my guess is if you only had a car, but you didn't have a telephone, maybe this is someone who tends to be more rural, and maybe they were more in favor of unions and the Democratic Party. And sure, if they only had a car, 59% of them ended up voting for Roosevelt. Telephone only. So this is probably people that, they're kind of living in the city, maybe a little bit more impoverished. They tend to maybe vote more Democrat. Telephone only 61%. If you had neither, right, you're probably really poor. Oh, sorry. Oops, they were even more likely to vote for Roosevelt. So the problem is only one of these categories was represented in our sample. And this specific category was only 27% of the overall population. Okay. So here we can see automatically we're going to have a selection bias. Because we were kind of choosing to these names by car and telephone, we're going to end up with a selection bias, and we made the wrong prediction. They also then looked at, was there a non-response bias? For whatever reason, do Republicans or Democrats respond more to this survey? Well, if you owned a car or a telephone, right, they actually didn't look at the survey specifically. They sent out another survey, right, and were able to, oh, sorry, they had the names of these people, sent out another survey, see if they returned it, right? And what they found was people that voted for Landon in every single one of these categories, notice for whatever reason, they were more likely to send back that survey. So, sometimes we can't predict this. Why is this? Maybe there's some story you could tell. That, poor, lower income tend to vote for Democratic candidates. Lower income have less time to put towards frivolous things like responding to a political survey. But here we've got a non-response bias as well. And here it wouldn't have mattered if we didn't have the selection bias, right? Even if we got names from the car and the telephone, or if you're in neither, like, we got names completely randomly, we'd still have this non-response bias that led us to the incorrect prediction. Okay. So what else can go wrong? So, you know, non-response bias is one thing, but people might also just maliciously lie to you. So, when it comes to like the drug use example I said earlier, it's hard to get good data on that because there's usually a bias in there because people underreport how much they use, or they just lie about using drugs, or alcohol, or whatever the kind of thing you're thinking about is. People might just misunderstand the question. So you got to think really carefully when you're doing surveys, like, am I asking this in a way that's going to be universally understood? So, maybe I ask you, oh, uh, how many days last, or how many times did you, um, I don't know, visit the grocery store last week? Well, maybe some people think, okay, that's how many days did I stop by? How many times did I actually go in? Well, I went to the grocery store twice in the same day in that one day, so I count that as twice. Some people might just misunderstand the question, right? So just kind of some easy toy examples. So if I asked everybody here, like, okay, rate your health from 1 to 4, I then collect all of the data from the class and say, okay, here's the mean, here's the variance. Why might I get a mean from that sample that doesn't match up with what the population mean would look like? Well, first of all, most people are unlikely to like think they're in bad health. I mean, I guess this could go the other way. Some people either believe they're in way better health than they actually are, and then there's plenty of people who are like, hypochondriacs and think that they're in much worse health. So I might have people lying one or the other, but it's hard to say which way this bias would go, right? Maybe people just read the question carefully if this is part of a larger or don't read the question carefully. If this is part of a larger survey, they might say, okay, 1 should be the best, right? That's the best health rating, and 4 is the worst. Well, the way this was actually set up, 1 was excellent, 4 is poor. Well, maybe I flip-flop that, right? Maybe I thought, oh, the higher number is actually better health, and so I responded with a 4 instead of a 1. Right? And actually, this doesn't match up. It's actually should, I think I had it here. So 4 is not response. There we go. All right. It might be hard if I do present a question like this with limited options. It may be that I don't feel like I'm belong to any of those categories. I feel like I'm in between them. So I feel like I'm like a 2.5. You forced me to have to lie to you because I don't feel like a 2. I don't feel like a 3. I feel like a 2.5. So anytime we have discrete options, we're going to have a little bit of kind of margin of error there. Right? Think of a second one, right? Also, I didn't put this up here. Why am I, if I asked, you students, why is there likely to be a selection bias there? You're all young. I would hope that the average health amongst you is probably better than the whole population, which includes 80-year-olds, right? So I have a bit of a selection bias if that's how I was going to do this survey. What if I asked how many alcoholic drinks on average do to consume each week, right? 1 to 5, 6 to 12, more than 12. Well, if I asked all of you, why might I end up with biased data. Well, if you're not 21, you might not want to report to me that you consume any alcohol out of fear that, I don't know, I'm working with the local law enforcement or something like that, right? So you might have people just not respond, a non-response bias, or they might just lie and say zero. Um, you know, another thing is people lie, sometimes maliciously, sometimes not maliciously. A lot of people might want to underreport their drinking. They don't actually want to think about how much they're drinking a week. Some people want to be the guy at the, guy at the party who can brag about drinking X number of beers, and so they over exaggerate, right? Trying to, whatever. So, we might have people over underreporting. Who keeps track of how much you drink in college anyways, right? So like I'm not sitting there and keeping a tally. Like, I don't know, maybe I had 6, maybe I had 7. Maybe I tell you I'm in one of the categories because I don't really keep track. Also, once again, what's another selection bias I might have with this type of a question? The drinking habits of 18 to 22-year-olds are dramatically different than the drinking habits of the entire population. Especially thinking about the entire population, including, 80-year-olds, things like that. We're probably going to have a little bit higher of a mean from a sample of college students. Okay, so one more example to kind of think about selection, non-response bias, people lying, that I think is really relevant, although who knows, things are kind of up in the air right now what the next election is going to look like, I think. But at least we go back to the first time that Trump was elected, right? It was kind of a surprise. A lot of the polls, I said the last elections is actually going back 2 elections, but well, not the past one, but the one prior to that, right? So 2016. So why did almost all the polls incorrectly predict the last election? And this really kind of applied to 2020 as well. So you can really think about this as the last 2 elections. So we're going to have a selection bias when we're asking people about who they want to vote for. So what might have caused selection bias if I was just doing political polls and asking people, are you planning on voting for Donald Trump or not? Well, you know, polls are often taken in larger cities, tend to lean a little more to the left. So maybe I have some selection bias and I'm over kind of surveying people who are more likely to vote Democratic. Right? Um, Less educated people, maybe they're less likely to be involved in politics. Um, if they tend to lean more towards the right? So these are more like rural individuals. If they tend to be less educated, they lean more towards voting to the right. They're less likely to be politically involved. They're not going to be ending up in these political samples. So there might be some selection bias. I don't know. These are kind of a bit of a stretch. Um, but I do think the non-response bias kind of makes a lot of sense here. So who didn't respond to these political surveys or calls about the last 2 elections, right? Probably people who were going to vote for Trump were a little bit more likely to be like, yeah, I'm kind of leaning towards him. If I gun to my head, I would probably say I'd vote for Trump, but I don't really want to tell someone that. I'll just tell them I don't know or hang up, right? Unintended lying, right? People might have thought they were going to vote for the Democratic candidate, and then over time they realized, I don't know, kind of like the Trump a little bit more. I'm going to vote for him, right? Malicious lying, there's a paper I read, and they kind of coined this frame, shy Trumpers, people who knew they were going to vote for Trump, but they know it's not received socially very well. And so they just said they were going to vote for Biden. They don't care about some political poll, right? They're not going to, stick their neck out just to say they're going to vote for Trump when they know it's socially a little bit, not well received. Right? So anytime we're thinking about political polls, you really got to stop and think about what types of groups are more likely to end up in these political polls and how might certain groups be underrepresented? And do those groups tend to vote more Republican or Democrat? That's our selection bias. Non-response bias, if one of the candidates has a bit of a stigma associated with them, you might be less likely to get those people who are going to vote for that candidate to respond to your survey. And then always be kind of thinking about which way the line might go as well. All right, so that's kind of our setup for thinking about samples. I'm going to stop the video here and kind of make a part 2 where we actually look at, okay, once we have this sample, we could take not just one sample, we could take 50. If we took 50, what would the distribution of those sample means look like?